There are objects in this universe so extreme that the rules stop working near them. Not metaphorically. The actual laws of physics, gravity, time, even the shape of space itself, bend and then break. We have photographed exactly 2 of them. The first was released on April 10th, 2019, and every scientist who looked at it knew the same thing. We still cannot tell you what's inside. Nothing that goes in ever comes back out to tell us. So let's do the only thing we can. Let's fall in order, and see how far physics gets before it quits. First, kill the word. There is no hole. Nothing is being sucked anywhere. Imagine space and time as a stage, the grand stage the whole universe plays on. It isn't fixed. Put mass on it and it sags. Stars, planets, you. Everything makes a dip. Those dips are gravity. A black hole doesn't make a deeper dip. It makes a trapdoor. Before we fall any deeper, hit like and follow. Now, let's keep going. Here's how you make one, and you already know half of it. Every star is a standoff. Fusion at the core pushes out. Gravity pulls in. For billions of years, they tie. But fusion needs fuel, and fuel runs out. When it does, nothing pushes back. And in the final moments of a really massive star, the inside implodes at nearly a quarter of the speed of light. What's left is absurd. 10 times the mass of our sun, packed into a ball barely 60 kilometers, about 37 miles, across. There are roughly 100 million of these in our galaxy that we know about, which sounds alarming until you learn our own sun can never become one. It isn't heavy enough. That was proven by the astrophysicist Subrahmanyan Chandrasekhar. If the leftover core is below about 1.4 solar masses, it settles down into a white dwarf and stays there. So you are not living next door to a bomb. You're living next door to a star that will die politely. And then there's the competition. Supermassive black holes. Millions, even billions of times the mass of the sun, sitting at the center of just about every large galaxy, including ours. Ours is called Sagittarius A star, 4 million suns, in a ball smaller than Mercury's orbit. The largest we've found, TON 618, is 66 billion suns. Its event horizon, the boundary, is a sphere of darkness 400 billion kilometers across. Our entire solar system, Mercury out to Pluto, could vanish inside it with room left over. Now, we fall. And the first surprise is that the small ones are worse. Fall toward a stellar black hole feet first, and your feet are meaningfully closer than your head. Closer means they're pulled harder. So your feet accelerate away from your head. You stretch. Then you stretch more. Your body is squeezed thinner and straighter until you're a thin stream of hot plasma, and then a line of individual atoms. Physicists named this spaghettification. That is the real published term. Let's hope your superpower is elasticity. For an average stellar black hole, this starts several hundred kilometers out. You're destroyed long before you reach the edge. But go to the center of a galaxy, find a supermassive one, and the geometry flips. It's so vast that the pull on your feet and your head is nearly identical. There, spaghettification happens inside the boundary. So the biggest black holes in the universe are the only ones that would let you cross alive. So cross. And a look around. Gravity doesn't only pull on matter. Einstein showed it bends light too. Near a black hole, gravity bends light so hard that light stops traveling in straight lines and starts traveling in circles. There's a shell where this happens, called the photon sphere. Hover there. Look straight ahead, and you'd see the back of your own head. Light from behind your skull goes all the way around and comes back to your eyes in every direction. You'd be surrounded by yourself. And that ring of fire in every image isn't the black hole. It's the accretion disk, gas and dust caught in orbit, spinning at enormous speeds, with friction heating it to millions of degrees until it glows, which is the joke of the whole universe. The darkest objects that exist are wrapped in some of the brightest light there is. Interstellar rendered this almost perfectly. They hired a physicist who'd go on to win a Nobel Prize. But the color is wrong. That disk radiates far outside what your eyes can see. We paint it orange, so there's something to look at. And in the real image, one side of the ring is brighter. That's the side spinning toward us, an effect called Doppler beaming. So a blurry orange smudge quietly tells you which way a black hole is spinning. If you're still with me, drop a like and follow. We're about to cross the event horizon, and it only gets stranger from here. Now the part that rearranges people. Gravity doesn't just bend space, it bends time. The stronger the gravity, the slower your clock runs, and you never feel it. Your watch is fine. Your pulse is fine. Interstellar showed this correctly too. 1 hour on a planet close to a black hole, 7 years back on Earth. Look up from down there, and the universe is on fast forward. If you pulled away and flew home, eons could have passed. A one-way trip to a future where everyone you loved is already gone. Meanwhile, someone watching you through a telescope sees the exact opposite. To them, you slow down. Your light stretches redder, grows dimmer, your last seconds smeared across years. From the outside, you never fall in. You just fade, frozen at the edge, forever. 2 observers, 1 event. Both descriptions completely true. From your side, there's no wall, no flash, no warning. The void just rises up to meet you as fewer and fewer directions can still send you light, until everything you came from is a single bright dot behind you. Then the dot closes. You've crossed the event horizon, the point of no return, where escaping would mean traveling faster than light. Good luck with that. Inside, space and time are bent so badly that direction stops meaning anything. Every way you can move leads to the center. Turning, thrusting, fighting, all of it only gets you there sooner. Which gives us the strangest survival advice ever written down. To last the longest inside a black hole, you must do absolutely nothing. So what's at the bottom? General relativity has an answer, and the answer is that it doesn't have one. It says everything that ever fell in is crushed into a singularity. A point of zero size and infinite density, where the curvature of space becomes infinite, and our rules simply stop making sense. That's not a description. That's a divide by zero error in the universe. So Interstellar's 5-dimensional room? Pure imagination. And honestly, that's fair. The film hit the exact wall. Science hits and started writing fiction. We hit the same wall. But here's what we can say, and it's stranger than the Tesseract. A black hole has no memory. Throw in a star, a planet, a library, a person, and afterward it has exactly 3 properties: mass, spin, and electric charge. Every black hole in the universe is fundamentally the same object, the way every electron is the same object. Whatever you were isn't hidden in there. It's gone. And one more thing we almost never mention. Every black hole is spinning. They were born from collapsing stars that were already spinning, some at up to 90% of the speed of light. That rotation drags space itself around with it, creating a region called the ergosphere, where standing still is not an option. Not difficult. Impossible. Last thing. They don't last forever. Empty space isn't empty. It constantly sparks pairs of particles that instantly annihilate. But at the edge of a black hole, one can fall in while the other escapes. That escaping particle is Hawking radiation, and its energy is paid for out of the black hole itself. So they leak, they shrink, and at the very end, whatever's left evaporates in a final burst. A black hole with the mass of our sun would take about 10 to the 67th years to evaporate. The supermassive ones, around 10 to the 100th. Numbers like that mean nothing to a human brain, so try this. Imagine an hourglass holding 1 grain of sand for every particle in the universe, and 1 grain falls every 10 billion years. Wait for all of it to run out, and you haven't passed 1%. So will we ever really know what's inside? Maybe not. We can only ever see their outsides, and the theories we have are probably wrong about the middle. But it's all right not to know everything. It only means there's work left, mysteries still open, and big ideas still worth thinking about. That's the whole reason humans do science in the first place. And we've got time. The last black hole hasn't come close to melting away. If you made it this far, follow the page. I make one of these every week, and the next one is already strange. And here's the question. If you could safely look inside a black hole for just 1 minute, would you do it? Thanks for watching.